Hello. Well, we're about to hit 7,000 subscribers. We're like 25. Last I checked, 25 subscribers from 7,000. Wow. Thank you very much. Thanks everyone for the comments and all the thumbs up. Thumbs up's great, man. It helps my channel. Well, sorry I ain't had a video up earlier. I've been sick. I had a stomach flu, and on top of that, I have Crohn's disease. So it kind of magnifies it about 10 times. But anyway, to the design, this is what I've been studying, mainly to get this connected to as far as this ring underneath the eyes, so I can have this in like one piece. And it's not necessarily the outside of this ring, it's the inside to where the linkage connects to the servo. I got to make sure it has clearance. But also I'm going to try to join these two together. But you'll see me, I'm trying to study, because if I can cut this, horizontal to where I can print it like a flat plate, I like to do that because it helps with the supports. And I try to avoid supports if I can, even if I have to have multiple pieces. But, that's just the way I like it, because everybody knows that 3D prints, supports can suck. Now this is recorded as far as I've sped it up times 4, but you're seeing what I'm trying to edit here, and this is just part of it. You'll find out sometimes mirror seems to be off, so I'm having to make adjustments. Now, once again, it's at speed 4, and I'll remove a lot of stuff like the hourglass. My computer is about 12 years old. It's an i5, but it's still powerful and still does the job. So, but like I said earlier, that the measurement's a little off, and I'm talking like a, a quarter of a millimeter. And you don't think that's much, but it can, later on affect things. So what I'll usually do is just mirror again, and it's just me just editing. And what I did is I uh, linked up the interfacing faces and joined these blink mechs to this main support table here. And I'm just going in here and editing the inside to where all this needs to be removed. Like, you don't want to have anything that you're going to 3D print. You don't want any kind of, extra vertices or anything like that. So I just go in here and I edit all this and make sure it's clean, because that way, and I check everything on NetFab, make sure I don't have any, you know, problems with the print, because it sucks, because you have to do it. It's just part of it. But like these screw holes here, I'll just, once everything is set right, I'll just push them through again, as far as extrude them, and be new holes through the whole new plate. But it's just a little editing and getting everything set up just to get this one side of the mirror complete, so then that way I can just mirror it and it'll be all correct again. Here I'm just trying to, make sure I get one side correct before I mirror it. You know, I use NetFab to check, and sometimes it'll find errors, and I can't find the error they say is wrong. But and there's auto repair and stuff like that. But still, I like to try to fix it myself. So I have those two uh, IMAX connected to this main panel. So if I mirror one, I have to mirror the scalpel also. But it's just part of it. And then I'll keep it in mirror, and then that way, I won't physically join them into one piece yet. I'll wait, because I'm going to probably keep adding things to this base plate anyway. But as you see here, I got to make adjustments to this scalpel area here to where it has a little support that raises up about 5 millimeters. But I also have to make sure that that scaffold is level when it prints. I'm going to print the whole scaffold in one piece. And usually I find myself working on the right side, but and sometimes I'll switch it up, but you got to be careful, and that's when you'll, you know, mess up a mirror. And it's kind of hard to do that, but sometimes I mean, I'm talking about as far as, a quarter of a millimeter off, and it'll add up. You will see here that right here on the component on the left eye, that when I remove the component, it locks it onto the frame of the eyelid neck. So I know I'm going to have to just remove this whole section anyway. So basically I just highlight this whole side and just delete it and just clean up any vertices, lines. I know I had a few comments on people. They hear me breathing, but I don't have, I mean, I just have a simple mic, ain't no high dollar microphone. So I apologize if y'all hear me breathing. It's just I have a close mic. If I have it away from me, you can't really hear me that well. Another thing about mirror is that you can go back to it if you want to make another animatronic. You can use this again as like, from a library. But you can only go so close to where the linkage is hit. But then you have to either change to two servos to one servo. That way you can control them with one. But that will kill the mirror design. But it's fun though. But you'll see here where I'm trying to work out this so-called ring under the eye. And I just have to make adjustments to this ring so I can have clearance on the mouth or the lip hinge. I got to make sure I have clearance there, but I also want to join that ring to like the bridge of the nose and things like that. All that needs to be filled in because I'm going to have skin attached to it too. I don't want an empty space there because that skin will be baggy, but yet it could produce a weird kind of movement when I'm moving the lips. But I would prefer to have something to stick the very upper top of the lip there so it would just curl up the upper lip itself. But a lot of this design stuff here, like, I want to be able to make sure that that second part of that ring is the same flatness as that first ring. So I have to make, little plates to do that interface with mesh so it'll be flat. But that flat part's going to be connected to that support of the lids. And I make mistakes, and also I design things, and I says, well, no, this is not going to work. So, and I'll end up recording all of it, but then I'll just trash it all, and then start over and do a different process. But I'm just trying to get some kind of and this is where I'm wanting it to be critical, is the inside layer to where that hinge mechanism connects. The linkages have to have clearance, and I can't be bumping on anything in there because it's just going to ruin the whole effect. Then you have to either redesign it and print it. It's just foreseeing what I need to do. But another thing I've been working on too, if you when you design these things, you have servos, and that's the primary key to the animatronic. Have something move the so-called object. You have to have the servo motor. But if you can't find the servo you need, or you can't find a certain type or size or shape, and you have to, I mean, there's thousands of servos to choose from. And like for instance here, I want to make sure that I have another plan, like these servos will work also. So what I do is I search the internet and make sure that I have a plan B. And just like right here, I'm making servo sockets for these servos. But I want to keep my servos in this head the same. You know, have them 8 of the same size, like 8 wing servos or 8 sub micro servos, because you know I have my subscribers eventually will be on Patreon, and I need to make sure that I have plenty of servos available for y'all to get or order through me or order through a certain link I provide, and then yet you can find some available, but yet they might only have 3 instead of 8. But if we have 7,000 subscribers here and half of y'all joined Patreon, we got to make sure we have a lot of servos, for this animatronic to work. But I've been talking to, a lot of suppliers just to make sure that we have this available. But as far as another little trick, what you can do, if all the servos are the same size, let's go up even bigger. So what I do is I'll take a measurement, once again, of the so-called screw point, which I know it's 28 millimeters. So I can take a measurement of a standard servo, which is pretty large. It's a standard size servo that probably everybody has seen, as you see here. So it's 48 millimeters. So I'm going to make this measurement here with a tape measure on SketchUp 2017, and I'll tell it to be 48 millimeters. So what does that do? That makes every screw point in the animatronic to be 48 millimeters, and I've just enlarged the entire animatronic. So you can see the size comparison. If I had standard servos, all standard servos, this is how much bigger the animatronic would be. And that's just making the adjustment to the servo. Instead of 28, it'd be 48. Now here's an early design of a Grogu, and I made several of these things. And see, there's a different process with animatronics. If during the pop culture thing, is just that everybody says, well, no, it's this size, no, it's that size, no, the eyes are this big, and really nobody knows. They're just guessing. But uh, but like I made several versions of this, but mainly there's a different process when you're doing something than what I'm doing. I'm creating a new alien, my design, and I'm doing it this way. But when you have like this baby that I've been designing for a client, a doll maker, and I've been working on this for some time now, but everything has to be precise so we can get a skin on this baby. But what I had to go through was I took she sent me a baby that was silicone, and I took measurements of the baby. But I'm using so-called calipers, and I had to make a core, and this core is modeled from the skull, as you see here. And I filled in all the spaces, where the eyelids go and the mouth and stuff like that. So I sent that core to her, and she did a sculpture on it. And I'll show you that now. But as you see here, she sculpted the entire head on here, and I removed half of it so I could get a profile picture on how thick it is. Now, my measurements were off, but I'm measuring from a different baby size. And I measured the eyes with calipers and took all the measurement. The wideness is correct, but around the mouth and how the mouth is puffy, so I redesigned a new core to go by. And then I'll wait for her to resculpt that, and that way I can go and adjust it, and I had to make a new core so then you can sculpt it. But see, this is a different process than what we're doing on the so-called alien creature we're designing now. This is that we're designing it because this is digital sculpting, and clay sculpting can be done the same way. Like when I make the core of the alien, you could sculpt whatever you want on it, but you just have to be careful on your thicknesses because you don't want your silicone to be thick. And that's the whole key. We're trying to do our best to keep it very thin. And I'm saying maybe under 5 millimeters thickness. Now see, this is the silicone baby, and as you see here, I took the measurements of the eyes, and this was before I've even done anything. And she's a really good sculptor, and she sculpted all these lifelike silicone babies, and she sent me the core. I mean, she sent me the sculpture as you see here, and I'm making adjustments even where I'm pushing a tool through the clay to get the proper measurements. But this is the original right here, and I'm trying to just match it up to what I have from the baby. But having the eyes have eyelids and things like that makes it kind of not anatomy correct. So, but this would be a key tool to use, would be a scanner, a 3D scanner. But once again, it's a different process because this is working. The alien creature is working inside out, and the baby creature or the baby newborn is working outside in, and that can be difficult because if you're doing it free-handed or without digital help. But as you see here, here's the lid, the new lid for the skull. But as as far as how much I replace uh, the parts on the core, I'm going to have to replace the parts on the original skull, the animatronic part, and then I can make adjustments to the face also to where the cheeks will just be sliced, so I can have it move those cheeks connected to the top of or the face part of the animatronic. But you see here, here's how big the animatronic here, the creature compared to the baby. Once again, I'd like to thank everyone for the support. Thank you for the comments and the thumbs up. And just overall, really, I thank you so much. And y'all have a good day. Later.